Okay, this is lesson 1.1 and it's on relations and functions. And what we're going to do in this lesson is determine whether a relation is a function and know how to find the domain and range of any relation or function. Also evaluate functions. It says a relation is any set of ordered pairs. The domain is the set of all the x's. The range is the set of all the y's. And then we're going to look at something probably new to you. It's called interval notation. What it is if I start with an inequality, say 2 is less than or equal to x is less than or equal to 5, that can be written to 5. Basically, brackets go with equal to's, and if you look, the difference here to here is this has a line, this does not. So if I had 2 is less than x is less than 5, I would write it 2 comma 5. And the graph, what it would look like on our number line, would be box that's closed in with closed dots, and this one would be with open dots. And then you've got half open, half closed. That's where if you had the equal sign, it goes with the bracket. The not doesn't have an equal sign. It goes with the parentheses. So here I would have a closed one to the left and an open one to the right. And this one I would have an open one to the left and a closed one to the right. And then when it gets a little tricky is if you have an infinity in there. For example, x is greater than or equal to a. What it would look like, it would be closed and it would be going to the right like that, because remember the number line always looks like the inequality sign. And infinity is the farthest number to the right this way. Negative infinity is the farthest number to the left that way. So the way we would write it, let's just say this was 3. If I said x is greater than or equal to 3, the way I would write it in the interval notation would be from 3 to infinity. And then if it was open, the only difference there would be no bracket, if it did not have a line under it here. And then if it's going the other way, it's closed going this way, negative infinity is to the left, so negative infinity comes first, comma, if this was 3, let's just pretend, and it would be closed. If it was an open circle, negative infinity, 3, it would be open. We can never put a bracket on infinity because you can't close it in. Positive infinity always needs to be on the right, negative infinity always needs to be on the left, because that's where they would fall on a number line. Let's do a couple of examples. It says converting between intervals and inequalities. Convert interval notation to inequality notation or vice versa. Find the endpoints and state whether the interval is bounded, its type, and graph it.
The exam is in your box.
So if I had negative 6 to 3, negative 6 to 3, my x always goes in the middle. It has a bracket over here. Signs always point to the smaller number. It's because it has a bracket on the negative 6, it gets a line. Because it has a parentheses on the 3, it does not. What it would look like on a number line, negative 6 to 3, open, closed, shaded between. And let's see, don't worry about the bounded part and the type. Just know how to switch back and forth and graph it. Negative infinity to negative 1. If I graphed it first, negative 1 is here. It would be an open circle because it's a parentheses. Negative infinity would be here, so it's shaded this way. And that's x is less than, because the arrow on the number line and the sign always match. X is less than negative 1. The infinity ones are going to mess you up. Let's do a BB. Say I was doing 4 to infinity. 4 to infinity would look like this. I'd have 4. It'd be closed. Infinity's here, so it's going to be shaded between them. So that would be x is greater than or equal to 4. That's what that would look like. And then negative 2 to 3, bracket, bracket, negative 2, 3. Going that way is easy. And it's just shaded between negative 2 and 3. And they're brackets because there's lines under them. Okay. And then it says a function is, the definition of a function is a relation in which each element of the domain is paired with exactly one element in the range. The Ms. Tucker definition of that is the x's can't repeat. If the x's repeat, then it's not a function. So what you look for is you look to see if there's any x's that repeat. I got a 1, a 3, a 5, a 7, and a 1. So these two 1s repeated, so it is not a function. Here 1, 3, 5, 7, 9. So no x's repeated, so yes, it is a function. And then we want to look at it from a graph. To determine a function from a graph, you want to know if it passes the vertical line test. So what we'll do is we'll take a vertical line and we pass it across our graph. How many times does that graph hit that line right now? Well, 1. 1, 1, 1, 1, 1. It never hits more than once. So if that's the case, then yes, it's a function. What I mean by hit more than once, look right here. That's 1, 2 places that the graph hits the vertical line. If it hits the vertical line in more than one place, it is not a function. And if we look at C, hits it everywhere. By definition, everywhere is more than 1, so it would be no. Okay. Then we have the f of. We're plugging the numbers in. F of 3 just means I take the 3 and I put it where the x is. So it would be 4 times x, but x is 3, squared, minus 2 times x, but x is 3, plus 5, and I'm just going to use my calculator. 4 parentheses 3 squared minus 2, 3, plus 5, 35. I'm going to plug a negative 1 in where the x is, so f of negative 1 equals negative 1 cubed minus 1. Be real careful with this one. Order of operations, so we would do the negative 1 to the third first. So negative 1 to the third is negative 1. So then I've got negative negative. Well, that makes a positive. 1 minus 1 is 0. C is what's called a piecewise function. If you want to evaluate g of 6, you figure out where 6 would fall. Would 6 be less than 4, less than or equal to 4? Would 6 be between 4 and 10, or would 6 be greater than or equal to 10? Well, 6 would be between 4 and 10, so g of 6 means I fill the 6 in to the 3x. So g of 6 would equal 18. Then we have g of 10. Well, where would 10 be? Would 10 be less than 4? Would 10 be between 4 and 10? Or would 10 be greater than or equal to 10? Well, it would be the third one. So we would say 2 times 10 squared minus 15. 2 times 100 minus 15. 200 minus 15, 185. Now, D is f of a plus 2. So that means I put an a plus 2 where the x is. So instead of x, I put a plus 2 squared, plus 2 times x, but x is a plus 2 plus 1. And then I work it out. This is wrong. Don't write this down. That is wrong. You cannot distribute a squared across a plus sign. When you see squared, by definition, it means write me twice. So you have to write a plus 2 2 times. Okay, plus 2. I can go ahead and distribute that too. 2a plus 4 plus 1. A plus 2 times a plus 2, full. First, outer, inner, last. Plus 2a plus 4 plus 1. Combine like terms. There's a 2a, and a 2a. 2 plus 2 plus 2 is 6a. So a squared plus 6a plus 4 plus 4 plus 1. 4 plus 4 is 8 plus 1 is 9. Continuing doing the same thing. F of 4. These bars are absolute value. We're just filling it in. F of 4 is the absolute value of negative 3 times 4 plus 8. That's the absolute value of negative 12 plus 8. Do the inside first. That's the absolute value of negative 4, which is 4. Now, if you'll notice, I move kind of fast just to keep the length of the videos down, but you're going to want to stop, rewind, pause at any point where I'm moving too fast you can't keep up with me. Negative 2 minus 1 over negative 2 in parentheses squared. Do the top first. Negative 2 minus 1 is negative 3. Negative 2 squared is 4. Now, and this is probably brand new. It says name all values of x that are in the domain of f. Now, domain is what are the x values. So basically, what values of x are possible on this graph? Where does the graph live? There's two things in math that you cannot do. You cannot divide by 0. You cannot take the square root of a negative number. Okay? You can't do either one of those. No. So what we do is we look at it and we say, all right, in A, which situation do we have? Do we have divide by 0 or do we have the square root of a negative number? Well, we have divide. Basically, do we have a square root or do we have a bottom? This one has a bottom. The rule is if you have a bottom, you set it not equal to 0. And if you have something underneath a square root, you set it greater than or equal to 0. Because the bottom can't be 0. So to find what's in the domain, you just take the bottom and say that it can't be 0 and solve it. And you solve it just like you always solve it. Well, how do you get rid of subtract 5? Well, you would add 5. So x squared equals 5. And then how do you get rid of squared? You take the square root. The square root of 5 is the square root of 5, but anytime I take the square root of both sides, I have to remember to put plus or minus. So the domain, for now, is x is not equal to plus or minus the square root of 5. I don't know why I put the brackets. Those are unnecessary. On B, we have an under a square root situation, so I take what's under the square root, and I set it greater than or equal to 0. So minus 1, x is greater than or equal to negative 1, and that's my domain. In C, I have a bottom, so I take the bottom, I set it not equal to 0. Minus 1, x is not equal to negative 1. In D, I have a square root, so I take what's underneath the square root and set it greater than or equal to 0. So minus 4, x is greater than or equal to negative 4 if I take the square root. I can't take the square root of a negative number. So I get x is greater than or equal to undefined. What that means is there's no restriction, okay? The restriction does not exist. If the restriction does not exist, the domain is all real numbers. We'll talk about this more tomorrow. Kind of grab any questions that you have that don't make sense as we go along, and we'll always go over those in the warm-up the next day. E, you take what's underneath the square root and set it greater than or equal to 0. So x squared is greater than or equal to 25. X is greater than or equal to plus or minus 5. Now, I've got a problem. I can't have greater than or equal to positive and negative 5 at the same time. So I look at it and I say, this is going back to last year. Greater than or equal to, less than or equal to. Would that be a conjunction or a disjunction? And you're like, what? What is she talking about? Well, a disjunction, to me, if it looks like a D, it's a disjunction. If it looks like a C, it's a conjunction. A disjunction is connected by or. A conjunction is connected by and. So it's greater than or equal to, it's an or. So what it is x is greater than or equal to 5, or I have a negative, okay? If I have a negative, I switch my sign, less than or equal to negative 5. And we'll look at that more tomorrow. This is, again, determine whether the following are functions. So does it pass the vertical line test? That one does. This one does not. This one does not. This one does not. It hits in more than one place at the same time. That one, anytime it's shaded, it's a no. And this one's a no. We've already talked about that. And the last one is a yes. And that concludes 1.1. We are done.